Hello, ladies and gentlemen. Welcome back to math. Today, we're still covering what we've been covering the last few videos. We're still dealing with parallelograms. Okay, we're almost out. We're almost at the end. Anyways, so we've covered how to find out if a parallelogram is a parallelogram because of the sides. The two opposite sides are the same. Also, the opposite angles. Okay. Today we're gonna test those theories. Okay. Today we're gonna find out if coordinates that are given to us. Okay. A few coordinates that are given us. Four. Because remember, parallelogram has four corners. Okay. Four coordinates that are given to us to see if it really makes a parallelogram. Okay. So here's our problem for today. We have 4 points. We have point A, okay, which is located at -2 and 3. Okay. We have point B, which is located at 3 and 2. Point C is located 2, -1. And then finally, point D is located -3 and 0. Okay, so those are our 4 points. If you guys can't really see this, this is 2, -1, okay, for point C. All right, now that we have our points, I always like to graph it, okay, get into that habit to see how it looks like, okay. Some of us are a little more visual learners, okay. By seeing what we're dealing with, we can actually solve it. I like to graph it personally because this way I can know where each part is located at. So we have our graph. Okay. Now that we have our graph, I'm going to label it. 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4. Okay, and then -1, -2, -3, -4. Now that we have our graph, we're actually going to plot those points. So we're going to start off with point A. Notice that it says -2, 3. Okay, -2 is your x-axis. Your 3 is your y-axis. Okay, so x and y. So we can say -2. So we're going to go to -2, but we're not going to plot our point there because remember we have to go up 3 still because positive are up. So -2 and 3. So if I can get it right here, we have our first point, okay, which is point A. Now that we have that first point, okay, we're going to plug in the rest of the points, okay? So point B is at 3, 2. Again, the first one is x. Your second one is y. So +3 on the x. This time we're going to go to the right, our positives. So 1, 2, 3. But remember, we're not going to plug it in there. We're going to go up 2. So we go up 3 and 2. We have point B. Okay. Then we're going to plot point C, which is at 2 on the x-axis, -1 on the y-axis. Okay? Because remember, x-axis is horizontal, your y-axis is vertical. So we're going to plug it in +2, but this time instead of going up, we're going to go down because the y is negative. So we're going to go 2 on the positive side, because +2, and then -1. So we're going to go 2 and negative 1. There is point C. Okay? And then finally, our D, which is at negative 3 and 0. So X is negative 3, Y is 0. So again, this time we're going to go to the left because they're negative, negative 3. And we're not going to go anywhere because it doesn't go up or down. So we're going to put our point there. Okay? And that is point D. Now that we have our points, we're going to actually connect them. Okay? So we have from A to B to C, C to D, and then A to D. Okay? So now that we have it in here, we're going to actually test those theorems. Okay? We're going to test it. We're going to see if it's really a parallelogram. The way we're going to test it is we're going to use an equation that you guys are already familiar with. It's called slope formula. Okay? If you still don't know it or if you don't remember, okay, how to use it, your formula, first of all, is M, put it up here, M equals y2 minus y1 over x2 minus x1. Okay, that's the formula for slope. Okay, we covered this a while back. Anyways, now that we know the formula, what we're going to do is we're going to test the theorem, okay, with the formula. Meaning, we have to get A and B to find out the distance between A and B. We have to find the distance between B and C and D and A, okay? If your sides are the same, meaning if A and B is the same as D and C, and B and C is the same as A and D, then this is a parallelogram, okay? So let's test it out. Let's start off with A and B. So we have point A, point B. It really doesn't matter which one you choose, your first coordinate, your second coordinate, okay? Just keep in mind that whichever one you use, you keep X and Y the same. Meaning, if you choose A as your first coordinate, it's X1, Y1, and B would be X2, Y2. Okay? Don't put X1, Y2. It doesn't really work. So you have to choose the whole coordinate as a pair. So if this is 1, then that is 2. So we're going to put 1 for now, because remember, we're going to have to find A and B. So X1, Y1, X2, Y2. So now we're going to find this top part here. So what we're going to find it is, we'll do it over here on the side. We're going to have A and B, which is Y2, which in this case is 2. So AB equals Y2, which is 2, minus, because remember the formula is minus Y1, which in this case is 3, okay, over X2, which is 3, because remember that's X2, minus X1. Remember, guys, when this happens, okay, notice that you have a negative 2. You already have a negative in there. A negative in a negative makes it positive, okay? So it becomes plus 2. Now that we have that, we're going to actually solve it. We have 2 minus 3, which is negative 1, right? Because the bigger number is negative. In this case, it's 3. So equals negative 1 over 3 plus 2. Since they're both positive, we just add them, okay? 3 plus 2 is 5. Since it can no longer reduce, Okay, so there it already is a prime form or term. Your answer is negative 1 over 5. Okay, so negative 1/5. So AB is negative 1/5. So we're done with 1. We still have 3 more to go. Because remember, we start off BC, CD, DA. Okay. We're going to solve DC just to make sure we're on the right path. They both work. Okay. So again, we're going to use the same formula for slope. We have D, which in this case is negative 3 and 0. So that means that for C is 2 and negative 1. Again, it really doesn't matter which one you use as x1, y1, which one uses x2, y2. Okay? As long as, again, you use both of the terms, x and y, as the same number. Okay? Ones or twos. I'm going to use C as ones, D's as twos. Okay? So x1 for C, y1, x2, y2. So again, we're going to plug it in. Y2, in this case, is 0. So we have 0. Okay, wrong marker. It's almost dying. So we have 0 minus, because remember, the formula is minus, y1, which in this case is negative 1. Again, remember, you have a negative, and then the 1 has a negative, it becomes positive 1. So plus 1 over, again, we have x2, which in this case is negative 3, because we're using D as 2, negative 3 minus 2, right? Because remember, x1 is 2 in this case. So equals, again, 0 plus 1, it's just 1, over, remember, they're both negatives. Since they're both negatives, you keep the negative sign. So 3 minus 2, they're both negatives, so you can add them, it's 5. But you can never have a negative denominator. So the negative becomes the top part. So it becomes negative 1/5. Okay? So CD is negative 1/5. Notice the answer we got earlier and the one we got right now. Are they the same? They are, right? They're the same answer. So that means we're on the right track. Let's just let's hope that BC and AD are the same. Therefore, this is a parallelogram. So let's go ahead and try AD first. Again, A and D. Notice that I already have ones here and twos for D. I'm not going to worry about that because it's already in there. X1, Y1, X2, Y2. Okay? We're done for that part. So we have Y2, which in this case is 0. Because remember, the D is 0. I'm going to do it over here. So we have A, D equals 0 minus y1, which in this case is 3, right? So we have 3 over x2, which is negative 3. Okay, the next one is minus 2, right? Okay, so now we can actually say that since we have x2 as negative 3 minus x1 negative 2, but remember, since you had a negative there and you had a negative here, what are we missing in this equation here? Anything? We have negative 3 minus 2. The 2 becomes positive, right? Because 2 negatives. All right. So now we have 0. 0 minus 3, which is negative 3, over negative 3. Since we know negative is bigger, we know that our answer is negative. 3 plus 2. Since they're opposite, you're going to subtract them. 3 minus 2 is 1. Okay? Since negative 3 and negative 1 are both negatives, they can become positive. Okay? Try to get rid of that negativity. So they both become positives, since they're both negatives. It's the same answer. Positive, both positives, both negatives. So we have 3 over 1, which 1 can go into 3 times. So we know that AD is 3. Okay? We're almost done. All we need is one more. I'm going to use red. All right. So again, for the final one, we're going to use B and C. Notice that it's already x1, y1, x2, y2. I'm really not going to worry about that. Again, it doesn't really matter which one goes first, which one goes second. Okay, I'm going to leave it as it is. x1, y1, x2, y2. So we have, again, for the formula, for slope formula, we have y2, which in this case is 2. So we have BC. Oh, the marker did not work. That's not good. All right, so we have BC equals, again, we have y2, which in this case is 2, 2 minus y1, which if you guys remember, y1 is negative 1. Since again, 2 negatives make it positive, so we have plus 1 over x2, which in this case, for x2 is what? 3, right? So we have 3 minus x1, which is 2. Which our answer is 2 plus 1 is 3. 3 minus 2. Remember, you're subtracting. It's 1. So 1 can go into 3 times, right? So your answer is 3. So here's my question to you, now that we solved it. It was a lot of steps, I know, okay? It's very simple. It's all the same repeating cycle, okay? The only difference, obviously, you have to do it a few times. So by the end of this concept, you'll be professionals of using the formula, okay? Because you're going to use it four times. So on this problem, was it a parallelogram? It was, right? Because they're both negative 1/5, both opposite sides. And then the opposite sides on the sides are 3. Okay, so the vertical sides are 3s and the horizontals are negative 1/5. So yes, this is a parallelogram. Okay, I'm going to step out of the screen here for a minute, or for a second, should I say. Make sure you have all the notes. If you need to pause the video, go ahead and pause it. And then I'm going to go ahead and give you your assignment. Okay? All right. So make sure you have it all down. All right. So now that you have it down on your notes, if you needed more time, go ahead and rewind the video a little, pause the video. And so here's your assignment for today. All right, guys, so your assignment for today is, we have a few coordinates again, obviously. Again, coordinates, we have A is at 0, 0. Okay. We have B is at 1, 3. Then we have C equals, or C is at 5, comma, 3, and D is located at 4, comma, 0, okay? But that's not all. I'm going to give you one more just for practice, okay? Because I really want you guys to get in the hang of the slow formula. The reason why is because of your foundation for a lot of the math. Or a lot of the math, should I say. All right? So your other one is, we have K is at -1 and 1. Okay? L is located at 2, comma, 4. M is located at 6 and 4. And finally, N is located at 3 and 1. Okay? All right, so you have 2 problems on the board. You have the first one, okay, A, B, C, D. And then you have the second one, K, L, M, N. Okay, make sure you find if they're both. Let's do the one a little better here. All right, so make sure you do all 4 sides in each one. Okay, this way you can find out if it is or if it's not a parallelogram. Okay, remember the formula we're using is slope. Okay, make sure you submit a picture of your notes. Okay, guys, with your assignment. If you have any questions, let me know. Okay, try to get to them as soon as I can. All right, so make sure, again, you solve for both problems, and I'll be waiting for your email.